Hello students, welcome back. Let us continue with exercise 14.2 on page 245. Question number 6. 3 coins were tossed 30 times simultaneously. Each time the heads occurring was noted down as follows. So here we have the observation for 30 times that 3 coins were tossed simultaneously and the number of times that heads appeared. So when for the first time 3 coins were tossed, the number of times heads appeared was 0. So you will not really understand these observations until I explain you what exactly happens. Now when you are tossing 3 coins, first of all, one coin, the outcomes that are possible are heads, H for heads, and tails, right? So if you're tossing 3 coins, let's say for ones, what are the possible outcomes that we can have? Either we can have all 3 heads, or you can have all 3 tails, sorry, heads, 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 or you can have all 3 tails, or you can have 1 head, or you can have 2 heads, right? And these can switch also. For example, you can have tail, heads, heads, and you can have tail, tail, heads. And also there is another combination where you can have tail, heads, tails, or head, tails, heads, right? Because it depends on the coins. See, the outcomes are the same. Two tails, 1 head, 2 tails, 1 head. 2 heads, 1 tail, 2 heads, 1 tail. And 1 heads, 2 tails, 1 heads. So this is going to be, this will remain as it is. Tail, heads, tails, right? Or you can have head, tails, heads, right? So these are the outcomes that we can have. So now this is exactly the same representation. Let's say for the first time when the coin was tossed, there was no heads. That means it was this combination. The second time the 3 coins were tossed simultaneously, there was 1 head. So where do we have 1 head? We have it here, here, and here. So this, it could be either of these combinations. Similarly, these are for 30 times. These are the observations for 30 times that 3 coins were tossed. Now we need to prepare a frequency distribution table for the data above. So it's not been specified whether we need to draw a grouped frequency distribution table or an ungrouped frequency distribution table. So let's revise a little bit what we have learned about grouped and ungrouped frequency. Now ungrouped is where you can't really share the observation under one class. That is, you can't have it under one rate. So ungrouped, like we learned in the previous examples, we had blood groups, right? So blood groups can be A, B, AB, O, and so on, right? So can you just write a range like A to B, B to AB? No. These are individual unique values, right? And grouped was what? Where you can, in grouped frequency, you had class intervals 10 to 20, 20 to 30, and so on. So let's say we are talking about scores. So maybe there were 3 students who scored marks between the range 10 to 20. There were 8 students who scored between 20 to 30 marks. So these could be marks and these could be the number of students. So which one do you think we are going to use for this question, whether it's grouped or ungrouped? In my opinion, this will be ungrouped frequency distribution table. Why? Because here we have counts, right? We have counts of heads as 0, 1, 2, and 3. Why? Because heads could appear at no time, at 1 time, 2 times, and 3 times. So we are going to draw an ungrouped frequency distribution table. So please take a note of this. I'm just writing here ungrouped frequency distribution table. Okay. So here we need the headings. What is the heading going to be? The number of times that the coin was tossed, or number of heads. Right? Then tally marks and the frequency of the number of times that the heads appeared. So obviously the number of heads was either 0, 1, 2, 3, and finally we will write down the total. The total will be listed here and it should be equal to 30 because we have 30 such observations. So this is a pretty simple sum once you understand that which kind of frequency distribution table you are going to draw. So let's check all the values that are 0. So you have 0, 1, then 2, 3, 4, 5 and 6. So the frequency is 6. 5 plus 1 is 6. Let's move on to the number of times that the head appeared was 1. So 1, 2, 3, 4, 5, then again 1, 2, 3, 4, 5. So this is going to be 5 plus 5, which is 10. Proceeding with the third number, which is 2, or the third category, which is 2. So you have 1, 2, 3, 4, 5, 1, 2, 3 and 4. So 5 plus 4, 9. Proceeding with the last category, that is 3. So this is going to be 1, 2, 3, 4 and 5. So this is 5. Now let's do the total just to confirm whether we have striked off each observation. So 6 plus 5 is 11, 11 plus 9 is 20. Carry over 2, 2 plus 1 is 3. So 30. So this is the solution to your question number 6. Pretty simple, isn't it? Please take a look. Thank you for watching this video.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.